Hi, today we are going to talk about how to rotate a figure on a coordinate plane. So, when we rotate, we need to know a couple of pieces of information. The first thing we need to know is what direction, so either clockwise or counterclockwise. So, clockwise, if you imagine a clock, here I could even draw a pretend clock. Clockwise is this direction. So, clockwise is going to the right. That means the same direction as a clock. Counterclockwise is going the opposite direction of a clock. So that's going to the left or rotating to the left. So that's the first thing we need to know is what direction are we going? The second thing we need to know is how far are we going? Most commonly, you're just going to see some pretty easy degrees that we're rotating. So 90 degrees means really we're just moving from one quadrant to the next quadrant. 180 degrees means we're moving two quadrants over, so 1, 2. And 270 degrees means we're moving three quadrants, 1, 2, 3. And of course, you need to know the direction that we're going. But that's the most common types of rotations we're going to see. Definitely not the only kind. You certainly could be given any kind of degree measure. But in this video, we're just going to talk about these easier ones. So once you know the direction and how far, then you can actually start rotating. There are multiple ways to think about how to rotate a shape. Honestly, for myself, sometimes I literally pick up my graph and I actually turn it so that I can look at it and say, oh, okay, so now I see that point B is supposed to be pointing straight up when I do my rotation. And then I can put it back where it belonged, and then I can say, okay, now I have an idea of what it's supposed to look like. Now I can get to work and actually start working on my rotation. So in this case, we have to go 90 degrees clockwise. So clockwise is to the right. So if I imagine this big clock, I get here, this shape needs to go to this quadrant, which happens to be quadrant 4. And I'm going 90 degrees, so it's just one quadrant over. When I rotate, let's see, so I told you one strategy is taking your actual paper and rotating it around. I love that strategy. Another strategy is by looking at these coordinate points. So, for example, we go sideways 3 down 2 to point A. So it was sideways 3, so now I'm kind of rotating that. It's now up 3, sideways 2. So it was sideways 2, up 3. Sorry. It was sideways 3, down. So horizontal 3, vertical 2. So now we're kind of switching that. Vertical 3, horizontal 2. And that's going to be A prime. So now this one is horizontal 3, vertical 4. So we're going to switch it. We're going to go vertical 4, horizontal 3. Oh, I miscounted something. Let's see. 3, 1, 2, 3, 4. 3, 2, 3, 2. So 3. Oh, okay. Sorry about that. So vertical 3, horizontal 4. There we go. C prime. And you'll see, honestly and truthfully, this thought process I just went through is the reason I like to first turn my paper and look at it. Because when I do that, I can turn it and say, okay, I can see that point B is supposed to be on top. I can see that point A is supposed to be on the right side of the shape, and I can see that point C is supposed to be on the left side of the shape. And let's do our last one. B is 5 sideways. So now we're going to go 5 up, and then it's 3 vertical. So we're going to go 3 horizontal. So 1, 2, 3, 4, 5. 1, 2, 3. B prime. Whew, and there we go. Couple facts about rotations. Angles stay the same. So angle A is the same as angle A prime. B is the same as B prime, and the measure of C is the same as the measure of C prime. So angles stay the same and side lengths stay the same, which means triangle ABC is congruent to, it's the exact same size and the exact same shape as triangle A prime, B prime, and C prime. The only things that changed are obviously the location and the direction that it's pointing. B was pointing off to the side, and now you can see that B is pointing up instead. So that was rotating 90 degrees clockwise. Counterclockwise would just be going this direction 90 degrees, but the process is still the same. 3, 2, 3 was horizontal. So now we'll make 3 vertical and then 2. So A is going to end up here, and we'll call it A double prime. Now again, what I would do here is I would take my shape and I would physically turn it. So I can now see, oh, okay, now I see that B is actually going to be pointing down when I'm done with this. Okay, so now let's take C. It's 3 to the side, so it's going to be 3 down. And it was 4 down, so it's going to be 4 to the side for C double prime. And then B was 5 to the side, so it'll be 5 down. And what is that? 1, 2, 3. There we go. And that's B double prime. And same as before, these shapes are congruent. Well, congruent other than my drawing skills, but if I drew them perfectly, they would be congruent. So that is rotating figures.